Noted author and Harvard business professor David Garvin has helped everyone from the U.S. Army to LL Bean and Boeing Aircraft to General Electric. He's a world expert at showing these complex organization managers how they can build more effective learning organizations, how they can transfer knowledge, how they can improve both their organization and themselves by acquiring, interpreting, and applying this knowledge. Garvin knows the hands-on tools for kickstarting and sustaining this vital cultural learning process. Now he's even inspiring the wildland fire community with his critical hands-on organizational learning practices and guidelines. As these prescribed fire and fire use managers are about to learn, one of Garvin's most important tools is the decision-making process.
Learning's about improving. It's about getting better. It's about doing new things or doing old things better. Decision-making is about choices. And much of what you do on your job is you make important decisions. Now, I just want to sort of set the stage here. I want you to think just for a minute. We're not going to belabor this. But I want you to think about a poor or a flawed decision that you and your team recently made while fighting a fire. It can be a prescribed burn, or it can be fire suppression. Now, let me just give you some hints as you think about this. First of all, if it was a decision you made totally on your own, that's not a good one. I want one which you made with your team. Second, it shouldn't be a decision where it turned out badly because of things unforeseeable. The weather forecast said perfect weather, no winds. All of a sudden, a storm came up out of nowhere, not that. Think of a decision which had implications which, in hindsight, you could have anticipated. And as you think about this poor or flawed decision, I'm not going to ask you to share it. It's not about sharing dirty linen. I just want you to get a feel for decision-making processes. Here are some things to think about. What was the nature of the information and information sharing? What was the pattern of communication? What kind of conflict did you or did you not have in the group? If there was a minority position, how was that minority view handled? What was the actual reasoning process you used? And where, if at all, did you go wrong? Just take a few minutes by yourselves and just think through and jot down some characteristics of an experience you've had personally with a poor or flawed decision you made as a team. And you'll use it as a touchstone as we go through the rest of this. What I'm now going to do is show you a videotape. Let me explain to you what you're going to see. This is a TV reenactment of the decision-making meeting that was held between NASA and the Morton Thiokol engineers about the launch decision for the Challenger. So it's the issue around the O-rings and whether or not there's going to be blow-by, which is an escape of gases, which is what ultimately led to the disaster. Now, as you watch the video, I want you to think about two things. First, where are these people coming from? What's their motivation? What's their priorities? What are they trying to accomplish? And second, we know the outcome. What went wrong? As you see this, and this, by the way, is not word for word, but it is based on the transcripts from the hearings. So it is a pretty close enactment. We'll assume it's more or less accurate. And then what we'll do is a debrief. See if you see echoes of your own decision-making problems in what we see here. Runs for about 15 minutes.
Hey, Roger, you got a minute? Come on over. I hear you've had a couple of new thoughts.
Yes, I do. I wrote a memo to Bob Lund about it.
Well, what's the meat of it? Would you mind telling us?
Well, I think we've had a mistaken position. We believe we can get a new design going for the O-ring and continue to fly without any real worry.
So what's changed? We're working on the new design.
Well, we sure as hell have to keep flying. NASA's nearly doubled the schedule for next year.
I don't think we have to fly. I mean, we're sending those shuttles up like they can't fail or something. It's a different ballgame since Flight 17.
I don't see it's a different ballgame.
There's a problem, and we gotta fix it. Isn't that what you're saying, Roger?
I'm saying that, and I'm saying something else, too.
Well, come on, you have to play this for drama. Just say what you gotta say.
Since Flight 17, we know something we didn't know before. The primary O-ring can fail completely. If that ever happens in one of the major sections of the rocket, it's a jump ball as to whether the joint holds or fails. If it fails, there'll be a catastrophe of the highest order. Loss of human life. The shuttle, the launch pad, all of it.
Roger, you're keyed up about the O-ring problem because O-rings is what you work on. It's what you see every day. I want you to know there are other major problems on the shuttle. Cracks in the blades of the main engines, brakes, computer malfunctions. If any one of these fail, it could bring the same devastation you're talking about. Now, we got to fix this O-ring problem. There's no question about that. But, Roger, the shuttle has flown 19 times, and it's come back 19 times. Our job isn't to run around like Chicken Little hollering the sky is falling. It's to fix this problem, and when the next problem comes up, fix that and keep that shuttle flying.
I think everybody's hooked up. I want to say first that the booster recovery vessels are fighting a hell of a gale about 100 miles out to sea. As soon as this telecon's over, I'll have to see if Arnie Aldrich wants to launch without those vessels on station. Okay, Bob Lund, why don't you start?
This is Joe Kilminster. Earlier today, we were informed about the extremely low temperatures predicted for tomorrow morning's launch. The main question we're looking at is how the O-rings and the solid rocket booster would be affected. Now, we put together some charts with information from previous flights. We'll go over those and then make our recommendations.
Give us a minute, will you? The charts are just coming over the facts now.
Yeah, that's fine. Sorry about the delay. Arnie Thompson and Roger Boisgelet have been doing the research. They'll make the presentation. Arnie?
We have no data on O-rings operating at temperatures this low. But we've put together a rationale based on the information we have. The charts are mostly not typed, so if there's a problem reading them, let us know.
I'll begin by citing Flight 15, which was launched a year ago. The temperature at that launch was 53 degrees, which is the coldest reading experienced to date. We're faxing a chart now that shows the O-ring erosion on that flight. Any questions so far?
Go ahead, we've got the chart coming through.
The Air Force estimates 29 degrees at launch tomorrow morning. That is far below any temperature we've launched with before. So determining if this extreme cold will affect the O-rings, and if it does, how much is critical. The charts you're getting relate to that. The indication is that the cold-hardened O-rings will be slower in sealing. Therefore, there could be hot gas leakage past the primary seal, and because of that, increased danger of the backup O-ring being eroded.
So our recommendation is, you should see it on the sheet coming through now, not launching until the temperature is at least 53 degrees.
Whoa. Wait a minute. Am I looking at the right charts? Charts I've got don't support that conclusion.
They do. I think they do.
Well, I've listened to everything you've said, and I just don't see how you got that recommendation. It's not logical.
Why, it's perfectly logical.
Well, you began by saying what you're presenting can't be proved. And I agree, it can't. But now you're drawing serious conclusions from it, and you're making very serious recommendations.
Serious recommendations are called for.
Well, of course, that's why we're here. But what you're saying sounds like Morton Thiokol is establishing new launch commit criteria the night before a launch. Now, these solid rocket boosters have been operating under very definite specifications. You suddenly want to change them. You now want to base everything on this 53-degree benchmark. At that rate, it could be spring before the shuttle would fly. My God, Thiokol, when do you want me to launch? Next April?
I don't think we want to change launch commit criteria. We're trying to see if it's safe to launch with the O-rings experiencing these severe temperatures.
The benchmark of 53 degrees is based on my personal observation of Flight 15, where we had O-ring erosion and blow-by in both boosters. By blow-by, I mean the gases went right past the O-ring, didn't erode it, didn't even take the shine off it. That tells us lower temperature is a factor.
All right, I'm looking at your chart on Flight 15. There was erosion. But the worst erosion we've ever had was on Flight 2, and the temperature outside was 70 degrees. Now, where in what you're presenting is the correlation between low temperature and erosion? Your charts even seem to support the opposite.
I'm not talking about only erosion. I'm talking about blow-by is the important thing here.
All right, but where is the connection to low temperature? If the worst erosion occurred at 70 degrees, where is your data to support your idea of a connection between low temperature and erosion?
I don't have any other data than what I sent to you. But I saw with my own eyes there was a much larger arc of soot between the two O-rings. The soot was much blacker, and it penetrated all the way to the secondary ring, which is also scorched. When I say the grease was black, I mean it was black, just like coal. It was jet black.
Yeah, what does the color mean? Do you know? What engineering data supports your idea that the color of soot means something? Maybe it does, but what? It would be very dangerous to start guessing at it.
I have no other data than what I'm presenting to you. I have tried to get additional data as a member of the O-ring task force since last October, but I have not been successful.
I'm looking at some of your other charts. Oh, this chart on Flight 22, are you looking at that one?
Yes.
On Flight 22, there was also blow-by past the primary O-ring, right?
That's correct.
Yeah, but the temperature that day was 75 degrees. So I'm not clear what you're saying. If low temperature has a dangerous effect on the O-rings, why do we have both blow-by and erosion at 75 degrees?
I'm not talking about only erosion and damage to the O-ring. I'm talking about blow-by as revealed by the post-flight analysis of Flight 15, when the temperature was 53 degrees.
All right, how much erosion was there?
It was minor compared to other erosions, but it was black and sooty and more extensive.
Now, if you have no data to say what darker or lighter means, let's just leave color out of the equation. Now, you just said the erosion was more extensive. If it was, why didn't it burn the O-ring more?
I don't know the answer to that, but I know it looked worse.
You're saying it looked worse. The dark color made it seem worse. But the figures on your charts, which I'm looking at, say it wasn't worse. A direct relationship between O-ring performance and cold temperature is not supported by your data.
You're putting what I said into a different context.
I'm putting it into the context that I learned at engineering school. That you have to have reliable data to come to an engineering conclusion.
I don't have that data. All I'm saying is that launching it below freezing is an act away from goodness. All I'm saying is we should go by our experience base, as limited as that is. And our experience base says that at 53 degrees or less, we can expect increased erosion and blow-by.
This is Stan Reinhardt. Can I interrupt a second? Roger, it's my understanding that the solid rocket boosters are qualified by contract for operation between 40 and 90 degrees. This 53-degree specification would be setting a new benchmark. Are the solids qualified at 40 degrees or aren't they?
Let me ask something else. How come this wasn't brought up at the post-scrub meeting this afternoon? How come temperature as a function of O-ring performance has never been brought up before? 2 weeks ago, Columbia's launch was aborted 31 seconds before liftoff, and the temperature was 42 degrees. How come Morton Firecall didn't insist on this 53-degree minimum then? I'm sorry. I just don't get your recommendation.
It's away from goodness to make any other recommendation.
Listen, if being in the direction of goodness means wanting a successful result for this mission, I want that result. Everybody involved in this telecon wants it. Be reassured, Roger, you are not in the direction of goodness by yourself. But we've got an engineering decision to make here. And it's got to be made on quantifiable data. Now, Well, I want to ask Joe Kilminster for his recommendation.
Based on this presentation by our engineers here at Morton Thiokol, I can't recommend a launch.
I think we should get George Hardy's comments.
Well, let me ask first, does Thiokol have any more to transmit? Any further views? Because if not, I'm appalled that they could arrive at the recommendation not to launch, given the data that's been presented, especially so late on the evening before a launch. I agree with Larry Malloy. I make the same assessment he does. But if Thiokol recommends not launching, I'm certainly not going to override it.
We'd like to go offline for 5 minutes here and have a conference.
All right.
We have a management decision as much as an engineering decision.
Well, Hardy and Malloy are right about one thing. We don't have the data to support our recommendation.
I want to make sure I've got this. The worry is the temperatures in the 20s or 30s could cause the primary O-ring to seal more slowly. If it did, we could get some blow-by.
That's right.
But don't we have some tests that show how the O-rings
We have
behave?
tests showing that even if the blow-by cut 125 thousandths of an inch out of the O-ring, it would still seal.
Let me just show you, again, in the simplest terms, why I say we shouldn't launch at less than 53 degrees.
Even if we don't have 10 pages of historical data, there's only one right conclusion. Here, look at this picture of the black soot.
I'll tell you, it makes an impression on me if George Hardy says he's appalled at something we recommend.
His point is, and I think you have to listen to it, is that even if you get blow-by of the primary O-ring, the secondary O-ring is still in the proper position to seal.
Our charts may be inconclusive, our data insufficient, but everything we do have shows we'll be safer launching at 53 degrees or above.
That's clear. That's absolutely clear.
It's time to make a decision. Bob, take off your engineer's hat and put on your management hat.
You're right about that.
This is Joe Kilminster. We've assessed the data and reviewed all our charts. Even though we had some concerns about the low temperatures, we now recommend proceeding with the launch.
Does anyone in the loop have a different position?
I'll draft a letter and send it down tonight on the fax.
Well, let's go home now.
Okay. All right, well, I'll see you later. Yeah, good night, George.
Okay, what you've just seen and what you've just described is a very common mode of decision making. It often causes lots of problems. We'll call it advocacy. Okay? Hey, each party argues very strongly and deeply dug in for their point of view. You've all been parts of advocacy processes, dysfunctional advocacy processes. Now, here's what I want to brainstorm. What's the unstated rules of the game when you're participating in an advocacy decision-making process? You saw it played out here writ large. My point is right. Your point is wrong. What does winning mean in an advocacy proceeding? Everything. And winning is my view gets accepted. Okay, so it's I'm right, you're wrong. Goal is winning. Okay, what else is the rules of the game when you're in an advocacy proceeding? Mike?
If you disagree with me, you're not a team player. You're not committed to the mission.
Okay, anything you can do to denigrate the other side, fair game. Okay? Let's keep going. What are some other rules of the game? How do you handle information in an advocacy proceeding? Mike?
Don't confuse me with the facts.
What?
Don't confuse me with the facts.
Aha! What happens if there's information you have that's counter to your point of view? You ignore it? Do you even discuss it? If you can help it?
No.
What about minority points of view or dissenting views? How do you treat them? Dismiss them or even discredit them. So let's see what we got here. Discredit minority views. Suppress information. Counter to your views. Not a team player if you disagree. How else do you play this kind of decision-making process? Anything else? Aha, say a bit more about that.
Well, there was intimidation with Larry. I mean, you know, take your management hat off, or your engineering hat off, and put your management hat on, and
if you can't win with the facts, win with power. Right? Any other aspects of an advocacy process? Okay, now, imagine the opposite. We'll call it an inquiry process. Okay? Inquiry means we're out to learn. We're out to come up with the best possible solution. You've all been parts of processes like that. What are the characteristics? What are the unstated rules of the game of an inquiry process?
All ideas are welcome.
All ideas are welcome. How about dissenting views? Even those. Okay. What does winning mean when you're involved in an inquiry process? Does it mean that your view wins? What was it?
Getting the right answer.
Getting the right answer.
The best answer.
The best answer. Getting at the truth, whatever that may be. So here, winning equals the best answer. How do you process information in an inquiry process?
You ask questions.
You ask questions. You want to filter the information or have it come to everybody in the same raw form? Same raw form. Everybody should see the same data. How do you deal with information that's contrary to your position? Put it out there to discuss. Okay, so information is widely shared. Many flawed decisions come down to advocacy processes. Me against you, us against them, an unwillingness to listen an unwillingness to hear. And a lot of what I'm going to say in the next few minutes is, how do you get from advocacy processes to inquiry processes? I want to give you some tools. Unfortunately, we've had another disaster with Columbia. And it is very closely related to everything we talked about this morning about the need for a learning culture. That's the connection between learning and decision making. Now, I want to just read you some material from the reports on the Columbia disaster. Tuesday, January 22nd, 5 days after the foam had broken loose during liftoff. Remember, that's the problem. And some 30 engineers from NASA were having the first formal meeting to assess the potential damage. Virtually everyone in the room agreed that NASA should immediately get images of the impact. They elected one of their number, a soft-spoken engineer, to convey the idea to shuttle mission managers. He tried at least half a dozen times to get the space agency to make the request, to get the imagery. All of his efforts were turned aside, and a manager refused, he said, because he didn't want to be a Chicken Little. The Columbia flight director wrote a curt email message that concluded, "I consider it to be a dead issue." This is not actively encouraging dissent. Right? Now, want to reinforce that. This is an excerpt from the Columbia Accident Investigation Report. Perhaps most striking is the fact that management displayed no interest in understanding the problem of the debris strike and its implications, whether it was a safety of flight issue. In fact, their management techniques unknowingly imposed barriers that kept at bay both engineering concerns and dissenting views, and ultimately prevented them from seeing the danger. Now, here's the part that's most damaging, and I'd urge you to do some reflection on this. This is from an interview with Admiral Gaiman, who was the head of the Columbia Accident Board. And he says, "Oh, NASA management says all the right things. They say, we have open doors and emails. We say anybody who sees a problem can raise his hand, blow a whistle, and stop the whole process. But then when you look at how it really works, it's an incestuous hierarchical system with invisible rankings and a very strict informal chain of command. So even though you've got all the trappings of communication, you don't actually find communication. All the time you hear from the engineers, well, I was afraid to speak up. If I'd spoken up, it would have been at the cost of my job." Okay? It's more than just the trappings. Particularly, and the relevance here is to AARs. When you start running them, you have to actively solicit the dissenting views and find ways to get them on the table. NASA said all the right things, but they didn't actually do them. And this is what I want to focus on. Decision-making is a process. Just like learning is a process, decision-making is a process. Now, once again, there's a mythology out there. Okay, the mythology is the heroic view of decision-making. You're out on the fire line. There's a critical choice to be made. You face down the data, and you decide. Unfortunately, that's not the reality of decision-making. Decision-making is not solely an intellectual exercise. It's a social process. It's composed of many small acts carried out by different people at different points in time. Now, that has important implications. First, it means just like learning, you can find best practices. It's a process. There are better and worse ways to do the process. Second, it's often very hard to even say exactly when a decision was made. For those of you who are married, the easiest analogy is, when exactly did you decide to get married? It's not typically at the time of proposal. It's not even typically when you think you made the choice. And it's certainly not a solo decision. Your friends weighed in. Your family weighed in. People you didn't even know weighed in. And all of a sudden, it added up, and you finally said, yeah, I guess I'm getting married. It's very hard to pin down when precisely a decision is actually made. That's because it's such an extended process. Now, the other thing to recognize is that all good decisions have three characteristics. The first is you made a smart choice. That's decision quality. The second is people were willing to implement. And the third was you made the choice and the implementation in time. Now, it's worth thinking a little bit about these three criteria, because you can all think of situations where you met one or two, but not all three. You had a real high-quality choice and everybody implemented effectively 3 days too late. You had terrific implementation on time. Unfortunately, you made the wrong choice. Okay? Or any other combination. You get the idea. We had terrific choice. We did it quickly because I imposed it. And because nobody bought in, we never got effective implementation. That has a real important implication. You do different things to drive the different elements of decision making. Okay? Now, I want to spend a little bit of time on each of these, and we'll go through them a little bit more quickly than usual. To get decision quality, you need to cultivate constructive conflict. And I'll distinguish constructive conflict from destructive conflict. Just so you got it parked in your mind, if you remember the NASA tape, that was far more destructive than constructive conflict. And what you're after is divergent thinking. You want many different points of view. That leads to decision quality. If you demonstrate consideration, it's really a way of saying people believe the decision-making process was fair. It was done fair. Even though I had a minority point of view, I was heard. I had a chance to participate. That tends to build in commitment and understanding, and commitment and understanding yields implementation effectiveness. And then you've got to be able to strive for closure. Not so quickly. You move too quickly and you get groupthink. Nor so slowly that you defer and defer and defer because everybody gets a chance to weigh in multiple times. Think of a time when your team experienced too much conflict. And what were the implications? But then think of a time when there wasn't enough conflict. And what were the implications? One of the most important things you need to get conflict that's constructive is minority views. That was Roger's position. Now, why do you need minority views? Because they stimulate different perspectives. All decision-making requires you to spread out ideas before you come together. Now, it turns out minority views are important, but not for the reason most people think. In most cases, the O-rings example is an exception. In most cases, the minority view is not adopted. But what it does is it causes people to think more deeply about the main option on the table. And here I want to give you a very practical example. I actually went through this. For many years, I worked in the field of quality, and I was on the Malcolm Baldrige National Quality Award, the Board of Overseers. And I served with a man named Bob Galvin. Bob Galvin was CEO of Motorola for many years. He was chairman and part of the family founders. He's a revered manager. He's one of the great managers in American history. He grew that company from nothing. And while Galvin was on the board, 4 times over the course of 2 years, he did the same thing. We would be going in one direction on a decision, and all of a sudden he would say, let me just throw out an alternative view. And the alternative view was always the opposite of what we were proposing. So in one case, we were thinking of broadening the quality award criteria to include service companies. It was just manufacturing companies. And he said, well, I got an idea I want you to think about. Let's narrow it to an even smaller set of manufacturing companies. And I got to tell you, my reaction at that time was, that has got to be the stupidest idea I ever heard. Now, this being Bob Galvin, this is a very important guy. He was a hero of mine. I didn't say anything. And that time, as well as every other time he did this, the same 2 things happened. First, we always rejected his suggestion. And second, we always came to a better solution in the general vicinity where we were headed. That's the power of minority views. And I finally grabbed Galvin at one dinner and I said, okay, I've seen it 4 times. It's not a coincidence. Why are you doing this? He said, I actually set about studying a long time ago how you get people to think more creatively. And I found out one of the ways you do it is by you inject minority views. And I studied what were the best ways to do that. What's the timing, what's the format, and I practiced until I got good at it. Okay? That's why you need minority views. They deepen the group's level of shared understanding. Now, an important tip. If only one person is the minority, unless they're a Bob Galvin, they won't get listened to. It's one of the reasons why Roger gets overruled. He's a soloist. You need 2 or 3 people to hold down the minority point of view. So put together your groups with that in mind, including AARs. We had 1 dissenter in the way we set it up, but we had 2 or 3, there would have been a very different dynamic. Now, here's the other reason why you want to cultivate dissent. If you have a yes man working for you, one of you is redundant. You don't need somebody to tell you exactly what you already said. Okay? Now, here's the other thing that's important about conflict. There are 2 kinds of conflict. First kind is about the task at hand. It's about how we get the job done. It's about ideas. It's called cognitive. The other kind of conflict is emotional. It's about personal friction. Okay, let me show you how you judge which is which. Simple questions. You have a lot of cognitive conflict if there were lots of disagreements over ideas. If you have lots of differences about the content of the decision, with multiple alternatives, lots of points of view, there was lots of cognitive conflict. Affective or interpersonal conflict, how much anger was there? How much personal friction? Okay, quick quiz. Do you think cognitive conflict, debates about ideas, is generally desirable or undesirable? Desirable. Why? Helps you
ideas.
Gets more ideas out. Get the best ideas. It's creative. It's generally very healthy. Do you think affective conflict is generally desirable or undesirable? Undesirable. Why?
It takes away from where you're trying to go.
What was higher in the NASA videotape? Cognitive or affective conflict? Affective conflict. That's a demonstration of where the interpersonal frictions were way up. But the real debates over ideas were way down. What you want is exactly the opposite. Now, I frequently run exercises with teams where I put them in groups and I give them a tough challenge to deal with. The typical pattern is up the diagonal. If cognitive conflict is high, so is effective conflict. If there are lots of debates over ideas, there's lots of personal friction. Why do you think that's true? You think people are able to separate the two?
No, not too good.
People take debates personally. Now, what you see in the circle up on the left, Team 8, is pretty much the NASA picture. We didn't have too many debates over ideas, but we had lots of interpersonal frictions. That's the worst of all worlds. What you see in the lower right is the best of all worlds. We had lots of debates over ideas, but people didn't take it personally. Now, how do you get there? Because that's your job when you're leading a decision-making process. First thing you can do is, this is about climate. You can establish norms which say, we expect vigorous debates. Intel, which I mentioned to you before, literally has a norm called constructive conflict. And the CEO used to say whenever he was seeking out a decision-making team, he would try to find people he would call helpful Cassandras. Cassandra's from the Greek myth, who was always crying out that there's a problem. He'd literally put those people on his teams to get constructive conflict. Propose novel, unexpected questions that prompt debate without undermining an individual's position. This is the Bob Galvin example I just gave you. Posing the counterfactual, the hypothetical, the unexpected. Insist that debates be resolved by revisiting facts, assumptions, and decision criteria, not by power or the loudest voice. This is the one that Larry Malloy and Roger Boyce violated big time. They said, we're going to keep raising our voice until one of us outshouts the other. You can break up coalitions, and most important, you can choose your words carefully to avoid inflammatory language. I set up a team a while ago where I asked somebody to play the devil's advocate, actually play the role of taking the dissenting point of view. And I asked the team how it had gone afterwards, and they were off the map on personal friction. I said, I don't understand, what happened? And the devil's advocate said, yeah, I just can't understand what went wrong. I started out by saying, after they'd made their arguments, I want to thank you for making my job so easy by coming up with such stupid ideas. Obviously, that's the opposite of what you're trying to do. And what you saw, again, in the NASA tape was inflammatory language. As soon as Roger said, it's away from goodness, that debate was guaranteed to escalate. Because he was saying, I'm on the side of angels, you're not. Okay. Now, deeper challenge, implementation. CEOs, most organizational leaders, tend to overlook the lesson Moses learned several thousand years ago. Namely, that getting the 10 Commandments written down and communicated was the easy part. Getting them implemented was the challenge. Okay, now, again, I want you to think just for a few seconds. Turns out people are more willing to implement a decision even if they disagree with it, if they believe the decision-making process was fair. So think for a moment. Think of a process you recently participated in where you disagreed, but you still felt the process was fair. What goes into that kind of decision-making? What makes a decision-making process fair?
Both sides are looked at.
We look at both sides, give an equal opportunity to participate. What else?
Everybody is in agreement that the process or whatever you're going to look at is okay for them. It's safe ground.
Okay, we accept the process. Yes. The ground rules are laid out and we're willing to buy into the process. Anything else?
You got to have input prior to the decision.
Aha! The decision wasn't already made. You've all been in processes like that. The answer is X, Y, Z, but I want to hear your input. You're guaranteed that people won't believe that's a fair process. So to summarize, what are the components? Voice. Everybody's got a chance to put in their views. Consideration. Those views were actually listened to and weighed. Opportunity for influence. It wasn't a pre-made decision where we walked in and we had no opportunity to change the person's mind. And transparency. The process is clear to everybody. We know how we're going to get from beginning to end. So what are some things you can do? You can provide a process roadmap. Here's the way we're going to get there. Everybody agree, here's the way we're going to make the decision. Avoid a strongly stated initial position. If you know the answer already and your mind's not going to be changed, don't go through the charade. If you have a point of view, don't necessarily lead with your point of view if you're the most senior member of the group. Actively listening. Curtis gave us a simulation a while ago about active listening. Thoughtful questions, few interruptions, and playback. We talked about playback in AARs. And finally, and this is one most people don't do, after the decision has been made, provide an explanation. What was the rationale? How were different people's input used? And in particular, if somebody's views were overruled, why? How did I think about that and not decide to move on it? For what reasons? We promised you as part of the objectives to give you a checklist for decision making. This is it. It's really pretty simple. Now, here's the reason you need a checklist. The difficulty with decision making is that the outcomes aren't clear until time has gone by. So the best you can do is use a checklist to evaluate the process. We've got lots of research which suggests if you meet these tests in the level of process, your outcomes are likely to be better as well. So, what's the checklist? First, were there multiple alternatives? Now, the most important thing to recognize here is a go, no-go decision is not multiple alternatives. That's one option. Sometimes you have to generate an alternative. So I teach students about the Bay of Pigs and the Cuban Missile Crisis under President Kennedy. The Bay of Pigs was one option. Go, no go. Cuban Missile Crisis was two options. Blockade or bombing. Those are two quite different options as opposed to a go, no go choice. Second, do we test our underlying assumptions? Every organization is filled with assumptions that we absolutely positively know to be true. In NASA's case, unfortunately, leading up to Columbia, the absolute known to be true was foam cannot damage flightworthiness, simply because it had never before damaged flightworthiness. They were using a model, literally, which didn't have the parameters to match what happened to Columbia. Yet they said, we've got to assume because it never happened before, it won't happen this time. They didn't test their underlying assumptions. Well-defined criteria. Do we know the basis on which we're going to make our choice? This is very much akin to commander's intent. Do we have clear criteria, and do we revisit them? Dissent and debate. Were there minority views? Did we have active disagreement? Was there constructive conflict about ideas, not necessary emotional debates? And finally, do people believe the process was fair? If we went around and said, was it rigged? Or was it genuinely fair? People said, yeah, it was transparent. I had a chance to put in my say. I had a chance for influence. The decision wasn't fully made.
The Wildland Fire Lessons Learned Center is becoming a dynamic resource for the entire wildland fire community. This important presentation on the decision-making process, part of David Garvin's Building a More Effective Learning Organization workshop, was sponsored by the center. It's one of the center's many ongoing efforts to improve safe work performance and organizational learning for all of you who work in interagency wildland fire. The Wildland Fire Lessons Learned Center's goal is to provide the right information to the right people at the right time. In today's complex business of working in wildland fire, the center is dedicated to improving performance, safety, and efficiency. In doing so, the Wildland Fire Lessons Learned Center is here for you, designed to serve the entire incident management community, improve organizational learning, and share knowledge, and perhaps most importantly, to help promote organizational change.